All right, hello wonderful students. If you're watching this video, it is because you are trying to review how to do this electron configuration notation that we learned in class. So hopefully this video will be helpful for you. It is one of the hardest chemistry concepts, but you can do it. I believe in you. That is why I'm making these videos. So to show you what the configuration looks like, the big numbers represent the shells or the principal energy levels. So everything with a 1, that would be the first energy level or first shell. Everything with a 2, that represents the second shell. 3, third shell, and so on and so forth. We can have up to 7 shells. We probably won't do one with 7 shells because that's a whole lot of electrons. So anyway, the letters represent the orbitals that we learned about. So those are the little weird shaped things that if you're looking at the slideshow, everything has one s orbital. Once we get to the second shell, we add 3 p orbitals. Once we get to the third shell, we add 5 d orbitals. And then once we get to the fourth shell, we add these weird f orbitals. So the little tiny numbers represent the number of electrons that we have in this atom or in this orbital. So in the 2p orbital, we have 6 total electrons. So if we wanted to know the total number of electrons in this whole atom, we could just add these up. So it would be 2 plus 2 plus 6 plus 1, 11 total electrons. If we wanted to know the number of valence electrons, so the outer shell, we would go to our outer shell. So our biggest number is 3. And there's how many I have, 1 valence electron. So hopefully this will help us. We're going to go over the different tools we have to write our own electron configurations. So first things first, you should have gotten a paper that looks like this, the little resource sheet. And I've drawn these diagonal lines through these orbitals here, and then followed those diagonal lines to write my orbitals in order of increasing energy. So if you see, I have 1s, and I wrote down 1s, and then 2s, and then I did 2p3s, 3p4s, 3d4p5s. So you notice I have a 3p, and then I go to 4s, and then I go back to 3d, back to the third shell. That seems like it's wrong. It's not. This is when it gets to the bottom like this, when it gets complicated and we start putting electrons in out of order. That's why we have these tools to help us. This is an orbital diagram. We'll talk about that later. And then this is the periodic table version of the electron configuration, and this is going to be very helpful for us when writing electron configuration. So let's do one together. Let's do the electron configuration for carbon. So first thing I need to know is how many electrons carbon has total. So I look at my periodic table and I see that carbon has an atomic number, I don't know if you can even see that, atomic number of 6. So I need 6 electrons, and I have to find their spot in the orbitals. So my trick to do this with the periodic table is to find carbon's location on the periodic table and then find it here. So I'm in the second row, 4th column. And then I'm going to follow the periodic table like I'm reading a book. And I'm going to count the number of boxes to correspond with the number of electrons. So for example, I start right here, and 1s is my first orbital that I see. So I write down 1s. There it is. And I see 1, 2, 2 1s boxes. So that means I have 2 electrons. So 1s, 2. And then because as we're increasing atomic number, we're increasing the number of electrons. So that's why the number of boxes represents the number of electrons. Okay, so I did my 1s, and now I'm going down here like I'm reading a book. And I see 2s, so I'm going to write down 2s. And I have 2 2s boxes. So 1, 2. Perfect. And then I need to stop right here. I have more 2p boxes than I do the other ones. That is because every shell has 3p orbitals, not just 1 orbital, and every orbital can hold 2 electrons. But I need to write it for carbon, which is this box right here, so I don't need to go past that. So I count 1, 2, and I stop right there because that's carbon. That's the element I was looking for. So I'm going to write 2p2, and that is my electron configuration for carbon done. You did it. Yay, so great. Okay, let's do it for a bigger one. So scandium, and I'm going to make sure I have enough room. So I start again with 1s, and I have 2 boxes, so 1s, 2. And then I go to 2s, 2s2, 2p. I start right here, and I have 1, 2, 3, 4, 5, 6, so 2p6. I go to my next row, 3s, and I have 2 boxes, so 3s2. And then 3p6, I'm going to go down here to 4s, and I have 2 boxes 4s2. And then notice here's scandium. I should have pointed to that at the beginning, but there it is. And I'm going to stop right here. That is the 3d orbital, so 3d1. I didn't give myself enough room. Anyway, this is the official electron configuration for scandium. And you notice we start putting things in the 4th orbital, and then we go back to the 3rd orbital, or I'm sorry, 3rd shell. So if I'm looking for valence electrons, I need to look for my biggest number. So I would have probably 2 valence electrons. Once again, though, if we're going into these transition elements, the valence electrons rule with the columns doesn't really apply. Anyway, so that's that. Let's talk about the orbital diagrams on the back. So there's that. And we did this in class with little cups and pom-poms. And this diagram shows it in increasing energy, which is very helpful. You might see a diagram like this and have to fill this out. And it's not an increasing energy, which is why this diagram is helpful for us. So please remember we can draw arrows to represent electrons, and if you have a pair of electrons in a box, they need to have opposite spins. So this is asking us for the electron configuration for nitrogen, or the orbital diagram for nitrogen. And so nitrogen's right here, has 7 total electrons, so we need to make sure that we put 7 arrows somewhere on this diagram. So I'm going to fill in my lowest energy first, which is 1s. And according to my rule about the opposite spins, I would draw 2 arrows, 1 up, 1 down. Okay, I'm going to go to my next highest one. There it is. Okay, so I have 4 total electrons. I need 3 more. And please remember this rule, Hund's rule, that we learned about in class, where you need to fill in every orbital with an electron before you can go back and pair them. And you know when you need to do that based on if the boxes are attached or not. 2s has slightly lower energy than 2p. So we can fill in 2s first, and then when we get to 2p, that is when we need to be distributing our electrons before we can pair them. So I need 3 more electrons because I have 4. I need a total of 7, so I would have 1, 2, and 3. So that would be correct. So a common mistake would then be, should have brought an eraser over here. Anyway, a common mistake would be to do this. Oh, I have my 3 more electrons, perfect. That's not correct. We need to just, because we have an empty orbital and a pair. You can't have an empty orbital and a pair. So this would be my correct answer. Let's say, for example, we wanted to do oxygen instead of nitrogen, which would have 8 electrons. So then I could go back, once I have all these distributed, then I can go back and pair them, and this would be the correct orbital diagram for oxygen. And that is true when we did our Lewis dot diagrams. If you remember, I told you this is oxygen. You need to distribute on each side before you can pair. And so there's my 6 valence electrons, and I know I have 6 valence electrons because of my outer shell here is 2. 1, 2, 3, 4, 5, 6. So that would be my Lewis dot diagram for oxygen. Okay. I know this has been a long video, but I hope that it is helpful for you in figuring out how to do electron configuration. So thank you for watching. Have a wonderful, beautiful day. Goodbye.